Alrighty, this is Tommy Reed. I want to show you a little update. I ended up building the first hydraulic combustion turbine engine. And I'll explain a little bit in detail. Basically what it is we're eliminating the piston, crankshaft, and piston rod in normal engines. So we're actually using liquid as the piston. And how this is accomplished is through a very unique process on the design. Basically, we're going to run propane or natural gas because that way it doesn't contaminate the liquid as other fuels can do that. What we have here is our pump. This is our main dry pump. It's very complex right now. You see all these little knobs. Once I get the sequence, I'll end up putting a microcontroller where it controls everything. And basically, this is probably one of the first low firing rate than any engine out there. A normal engine can fire anywhere between, up to 1,800 times per minute, especially running at 3,600 RPMs. This at a 1 kilowatt, this is actually a 1 kilowatt. It's about 2 to 3 kilowatts tops, but it has to do all the charging and stuff on a battery bank. But this actually is not free energy. We're using natural gas or propane, and basically what we're doing here is a very unique process. What happens is that this pump moves the fluid upward into this combustion chamber, especially designed for this. These are rated around 7,000 psi max. I don't have a heat exchanger in there, which this will definitely need once it starts to fire multiple times. But the unique thing about it is this is basically a 0.6 liter each container. These are my 4 accumulators that stores a lot of potential energy. But this is equal to, on this 6.6 liter, almost about 619 cc's, which is pretty high. But the cool thing about it, this will only have to fire 10 times a minute to gain the pressure I need to generate the 1,000 watts of continuous power. And basically all the valves is just the way things are routed. I can't get too much into that. And I do have a patent pending on it, so I made sure I covered my butt on that. But I want to show the concept of this. There is actually a turbine engine. This is actually a turbine inside, a liquid turbine, actually. You might say like a Hero engine. And then we also have the gear motor, too, that is also part of the main output. Everything I pretty much made by scrap. I had to make my own gears. Did the chain drive. I made it all from scratch. This is the real prototype. This does have a very unique characteristics to it. When I'm finished, I'm going to push a button and it's going to start up on its own. It does run on a 12-volt battery. So I got one here I'll probably end up using just to get it started. Once it gets started and that combustion chamber starts working, it's going to, when that pressure builds up to, it's set to 150 psi, which is a pretty good compression ratio compared to that. But propane can handle that. That's why you don't want to put any like gasoline or anything, because it's going to mix in the oil. It's a very special oil that I'm using in this is actually cooking oil. And the reason is it could actually hold its viscosity for a long period of time, unlike any other oil. So basically the plumbing is a little bit spaghetti, but it is a purpose of everything has to work the way it should. This is to the gear motor. This is pretty much the same thing as the pump. I do know how many times this needs to pump up. This only needs to spin, believe it or not, less than 100 revolutions just to fill this up. To fire this 10 times a minute is very possible. But the good thing is the amount of fuel you're going to save is off the charts, technically. Now, a prototype is a prototype until you actually have it running. But overall, I did some testing and everything else. I know what kind of pressure I need. We have a pressure gauge up to 2,000. We're going to easily reach it over 1,000 psi inside this chamber. But the heat is very critical, so I won't be able to run it for a long period of time because I have to put a heat exchanger. Actually, it's another containment that goes over this and submerges in complete cooling system. So the heat that can be generated can actually also heat a room or also use it for converting, dirty water into drinking water. Why not? This is a very powerful alternator. I ended up doing some rewiring on this. Basically, this is going to run about 2,000 RPMs, which I already had this up to speed by testing it. So I know it's going to put out the amount of power. The power output is actually very unique because the generator that I'm going to be using is just a 12-volt system. So I know this is going to put out over 200 amps. I'll use the inverter for the pure sine waves to put out the power. Everything else, just think of it as a hybrid generator, and that's basically what it is. But the unique thing is we're using liquid to replace the piston. That means there is no friction in that liquid. Every time that comes up and down, there's no friction in the cylinder itself. So you're not going to have any wear. Plus, you eliminate the crankshaft, the piston rod. And in fact, think of a water rocket at 1,000 psi. Let me tell you something right now. This is very powerful when you're using fluid. It's not compressed gas. It's not expanding gas due to gas laws. So we're using actually the pressure on top, pushing the fluid downward. And there's a cycle that it goes through where it has to bleed through and everything else. But overall, this is a very unique design. Took lots of years. It was based on the Clems engine, but the Clems engine always confused me because no matter how many ways I tried to build it, I found out the only way the Clems engine would actually work, there had to be some kind of external combustion that's taking place with a cooking oil, maybe micro bubbling. But this is actually something that progressed from all those prototypes. So this is pretty much what the update is. Anything else far as it's going to weigh about 200 pounds without the battery because it is very heavy. It could get up to 7,000 RPMs. Not a problem at all. So overall, around 2,000 should do what I need to do on this. And that's pretty much the update on this first liquid combustion engine or hydraulic combustion turbine engine. And this is pretty much the prototype. Tommy Reed, talk to you later.